All right, let's talk about something we walk on every single day, but probably never give a second thought to. Concrete. You know, it seems so solid, so permanent. But what if I told you it has a secret? It's actually designed to break. And those lines you see everywhere, they're not mistakes. They're the key to its survival.
I mean, you've seen it, right? A brand new driveway, a perfect sidewalk, and then, sooner or later, cracks start to appear. You might think, oh, they must have done a bad job. But the truth is way more interesting. That cracking isn't a bug, it's a feature.
You see, that slab of concrete under your feet is in a constant, silent war. It's being pushed and pulled by these massive forces that you can't even see. And this daily battle is what leads to those fractures that are often very predictable.
So, to really understand why concrete cracks, we first have to meet this invisible enemy. It all comes down to the hidden movement that's happening inside the material itself, all the time.
The main force we're talking about is a basic rule of physics: thermal expansion and contraction. It's super simple, really. Just like most things, when concrete gets hot, it expands. And when it gets cold, it shrinks. Sounds minor, but the forces involved are absolutely immense.
And this is where you can really picture that constant struggle. In the middle of summer, that slab is literally getting bigger, pushing against everything around it. Then, in the dead of winter, it's pulling back on itself, creating this incredible internal tension. It's kind of like a rubber band being stretched to its breaking point.
And here's the kicker. You can't stop this from happening. There's just no way. You can't tell a huge slab of concrete, hey, don't expand today. It's a fundamental law of nature. So trying to fight this force head-on, that's a losing battle every time.
Which brings us to this really brilliant engineering puzzle. If you know for a fact that something is going to break under all this stress, but you can't stop the stress itself, what do? How do you manage that failure that you know is coming?
And here it is. This is the simple, elegant, and kind of counterintuitive solution. Instead of trying to make concrete so ridiculously strong that it never, ever cracks, engineers do the exact opposite. They basically tell the crack precisely where it's allowed to go.
This brings us to the actual solution. It's called a control joint. You know, those lines we've been talking about. They're not for looks. Their whole job is to be a planned, strategic weakness in an otherwise strong surface.
So how does it work? Well, it's pretty clever. First, a shallow groove is cut into the surface of the wet concrete. Then, as all those invisible forces start to build up, the concrete looks for the easiest place to relieve that stress. And instead of just cracking randomly all over the place, it cracks neatly and cleanly right at the bottom of that groove, totally hidden from view.
But, and this is a big but, you have to get the details right. If you space those joints too far apart, the stress will just build up and find another weak point somewhere else. That's when you get those ugly random spiderweb cracks. Correct spacing, on the other hand, makes sure the stress always follows the path of least resistance, keeping the surface looking clean and intact.
Okay, so problem solved, right? We've controlled the cracking. But here's the twist. In solving that one problem, we've actually created a new one. That perfect, straight, hidden crack is now basically an open door.
And that brings us to the second super critical piece of this whole puzzle: protecting that planned weakness. Because if you don't, a whole new enemy is going to come along and exploit it.
And that enemy is water. An unsealed joint, even if it looks tiny, becomes a perfect channel that funnels water directly underneath the concrete slab. And that's where it can cause all sorts of problems. Yeah, once water gets in there, it's a disaster waiting to happen. In the winter, it freezes and expands. That's the whole freeze-thaw cycle. And it acts like a wedge, forcing that crack wider and wider every single year. Over time, it washes away the soil underneath, causing the whole slab to sink and fail. So the very joint that was designed to protect the concrete can end up being the thing that destroys it if it's not sealed up properly.
So now, let's put it all together. Because making concrete that actually lasts isn't about trying to make it invincible. It's about a really smart two-part strategy.
This table really sums it all up perfectly. Good design allows for movement, which means the cracking is controlled. Then, it seals out water, which maximizes durability. Bad design, on the other hand, tries to fight that movement. That leads to uncontrolled cracking, which lets water get in and ultimately ruins the whole thing. It's really the difference between a sidewalk that lasts for decades and one that needs to be torn up and replaced in just a few years.
So the bottom line is this. Those simple lines aren't just some afterthought. They are the single most important design element for figuring out whether a concrete structure is going to last a lifetime or fail after just a few seasons.
And now you know the secret. That simple groove isn't a crack or a flaw. It's a brilliant piece of engineering, silently managing these huge forces to keep our world from falling apart. It's a controlled failure, designed specifically for long-term success.